Good morning. It is Thursday. Where are we at? April 8th? Wow. Today, you're supposed to have finished all of these questions by today. You're supposed to have scanned them in. So if you haven't scanned them in, you need to scan them in. Okay? We're going to go over those. Then hopefully y'all brought your prints and reviews. And we're going to go through and work on your prints and reviews. Getting ready for the test, which is tomorrow. All right? So, a lot of y'all, a lot of y'all were able to find these online, you know, as far as the answers. You guys are really good about that. I went and tried to get them online. I couldn't find them, most of them online, but I have hard copies of them, so. I'm just going to put the responses up, and then if you have any questions, so we'll start with 1988. So to do your reactions, the anode, how do we determine, a lot of you ask me the question, how do we determine which one's the anode?
Well, the most negative right now.
Which one's going to be oxidized, so how do we determine which one's going to be reduced or oxidized?
Well, the most release.
The less reduction potential is going to get oxidized. The greater reduction potential, and think, just use it logically, the greater the reduction potential, the more likely it is to be the one reduced. Okay, because it's got a greater potential to be reduced. And so that's the positive value. So the more positive value gets reduced, the less positive value gets oxidized. Okay? So then E is just red minus ox, and these values you get from page 1105, or in the current test, they'll be given within the problem. Okay, then we have to do the Nernst equation to find well, not Nernst equation, just this. This is our equation I gave you on the board, and it's actually right behind the screen here. Okay, this is just putting delta G equals delta G, the two delta G equations. It's blank. Delta G, we learned is equal to negative RT, natural log K. Delta G is equal to negative NFE. So if you set these two to equal to one another, E turns out to equal this. These two are on the equation sheet. This one is not. But again, it's just these two things set to each other. Okay? We all good with that? Y'all are quiet today. This is your time to figure stuff out. Ask questions. And then D is your Nernst equation. Is everybody comfortable using Nernst equation? And when did you use the Nernst equation? When did we use the Nernst equation?
Concentration.
Concentrations are not standard, which is 1 molar. So if they're anything other than 1 molar, we're going to want to use the Nernst equation. All right, so that was 88. The next one is 92. 3. Okay, so here's the setup. You have this here. So obviously, what's missing? Salt bridge. And what's the function of the salt bridge?
To maintain electrical neutrality by letting ions flow.
Okay, to maintain electroneutrality by allowing electron to charge to flow between the cells. And make it charged, not electrons, because the reality is it's ions flowing through. Okay, so here are your responses. How do we know again? Again, the reducing agent is the thing being oxidized. You don't have to know that term any longer. The thing being reduced is the oxidizing agent. It's the thing causing something to be oxidized. The way it causes something to be oxidized is by itself being reduced. Okay, so the agent is always just the opposite. So chromium is the thing being oxidized. Copper is the thing being reduced. And again, how do we determine that? The cell potential. Now, again, you guys are mumbling so softly that now all I'm hearing is blah, 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 blah. Speak up. You have a mask on. I'm old. Everybody, the camera needs to hear. Okay? So, since copper is being reduced, it's the cathode. Remember, vowels stay together, consonants stay together. The salt bridge, transfer of ions, but not electrons. Notice it says not electrons. Transfer of ions or charge. An E cell decreases with the Nernst equation. You can do it in terms of log of Q, going up or down. Is that the whole thing? So pay attention on the salt bridge when you're answering and allow to maintain neutrality by allowing charge to flow, or ions.
For C, could you just do the math to
Yep.
justify it? Or
You most definitely can.
okay, so you don't have to like explain it in words?
No, I would just maybe at the end just saying, you know, according to Nernst equation above, it's got, and I would say, because it's asking does it increase or decrease, you need to say it increases or decreases because, and then just show your math. All right, so that's 93. Now, then, what was the next one?
96.
96.
Is the Nernst equation given, or do we have to remember that?
Nernst equation is not given. I thought they put it back on there, but when I went and just checked on the most current one that I have, it's not on there. Okay, remember that for a spontaneous reaction, E cell is going to be positive, and your justification are all those and so I think, didn't they give you just a super large K on that one? And so on that one, so you can just, that would be my best thing is, because K is so large, you know it's very product favored, therefore E cell will be positive. That would be the easiest explanation to me. Okay, so the oxidizing agent, again, is the thing being reduced. They asked that a lot in previous years, but they're not going to ask that anymore. Now, C, okay, you have E is equal to RT natural log of K, so as T increases, E is going to increase. You can think in terms of Le Chavalier's principle. You can't answer in terms of Le Chavalier's principle, but you know, you increase the temperature, it's going to make the reaction go more to the right. Now, if we put it into the Nernst equation, because at 60 degrees, you're no longer at standard conditions. Here, as T increases, okay, well, because we're still log of Q, we're still 1 molar over 1 molar, so this is still going to be equal 0. So then there's going to be no change in the temperature if you use this. But they only gave you 1 out of the 2 points for that answer. So I haven't seen this question in the past 10 years, so I wouldn't stress too much about that. But it's just really plugging in where's T equal in the equation. And then D is the Nernst equation. And then when the battery, when it reaches equilibrium, E cell is 0, that's when your battery's dead. Delta G equals 0 at equilibrium, so NFE, E is going to equal 0 as well. Okay. Now 2000. And you kind of get the points over here on the right. You can kind of see how you're doing. Ask questions if you missed it, if you don't understand it, let me help you. But I don't want to keep going over something if everybody's getting it. Somebody asked me this yesterday too. Note, phase designations are not required. Okay, so you don't have to say solid aqueous. Just write the equation. So on this one, if you just use 2, notice this is the one that they did with sig figs. Is this question? Does anybody have this question pulled up? I don't have it printed out. Actually, I do. This again is a hydrogen fuel cell. H2O2. Goes to 2 H2O plus O2. And when it decomposes. So which is being oxidized, which is being reduced? In hydrogen peroxide, what's the charge on each oxygen? -1, thank you. Okay, so it's a -2, this is +1, +2. So each oxygen is -1. What's the charge on, or the oxidation state of oxygen here? -2. What is it here? 0. What's hydrogen still here? So hydrogens did not change. So which substance is being oxidized, which substance is being reduced? Oxygen. Okay? When the same substance, same element is both oxidized and reduced in the same problem, this is a big word. It's called a disproportionation reaction. Big word. Disproportionation reaction. To do that, notice they're just doing the 2 half reactions combined. You just do the oxygen going to O2 and the oxygen. So this one is being reduced. So we write it as you would go H2O2 going to the half reaction. What is it? H2O2 with the O2 in it is this one. Okay? This one. And then you have that half reaction where we're going to making the water is this one. But this is the one being, this is being oxidized. This one going to here is being reduced. So forming the water is going to be on the right-hand side, forming the oxygen is going to be on the left-hand side. It's going to go in the reverse direction, I should say. This one's going to reverse and go that way. So I haven't seen one of these, having to do anything with a disproportionation reaction, maybe having to just know the definition in a multiple choice question. But I haven't seen anybody ever having to balance a disproportionation reaction. But it's just a fun word to know. And then the electrolysis down here at the bottom. Are we all good with that? Anybody else need it?
So you can be one off in the number of sig pigs and still get a point?
On those days, yes.
Okay.
Nowadays, they're going to grade 1 for the actual accurate sig pigs. But again, it's 1 point out of 50. So it's not
1 for the whole test.
1
not
for the
like
whole
per
test.
question.
Yeah. Now there might be 1 in multiple choice as well, but on the free response, it's only 1 point out of 50 is max they're going to do for sig pig. So it's not a big thing to stress about. All right, 2001. Going down, here we go. That's 2001, question 7. Notice the statement, some work must be shown to support this answer. Don't just do it on your calculator and put the answer. You just got to show the red minus ox. This is the explanation that I would know and learn. The Nernst equation. I'll move it up. Since K is greater than D, since K is greater than 1, E is positive.
On there, they use the natural log instead of the log.
But they don't have it, usually they got the 2.303 if it's going to be in the common log is on in there.
Okay.
And then 2002, we took this one on to like 3 pages. So how do we find limiting reactant? Speak up so I can hear. Find the moles of each. And so grams, obviously the moles is the molar mass. How do you take milliliters to moles? Molarity. Molarity times volume. So here times here. And then for me, you just divide this one by 2, and it's the lesser, smaller number, so it's the limiting reactant. Okay? They go through and just kind of do kind of the same thing here. We'll see here they're dividing by 2 right here. on that one, so that's the same thing. Did I skip a part? Where's B? Again, remember that I incorrectly told you that delta G came out to kilojoules, but it comes out to joules.
Oh, we have to put units on your test.
On this, because G is either going to be 89,000 or 89, you have to specify as a joule or kilojoule. So on E, it gives you two choices. Number one, the simplest answer is E cell is positive, therefore the reaction is spontaneous. But you could also relate it to delta G from previous, where you had delta G being negative. But note they say you have to say that delta G is negative. You can't just say it's spontaneous because of delta G. You got to specify that it's a negative value of delta G. Any questions on this one? Does it need, now you need me to move it up now? Is this a continuation of, was this part B? What is this? Yeah, this was part B. This should have been after the limiting reactant. On the base of the limiting reactant, you identified part 1. Determine the value of the zinc concentration after the reaction is complete. Okay? That's just a stoichiometry problem. We all good there? And then just your cell potential. This is part B. E red minus E ox. Now, I don't have the answers to 2003, so let's just talk about 2003. How do you know which one is going to, several different cells are constructed, write the balanced net equation where the reaction occurs, give the greatest positive E cell? What do we look for?
The highest one, the lowest one.
The highest one and the lowest one. Which one was the highest one? Which one was the lowest one? Copper was the highest. Okay, so what was the balanced equation then for that? If copper was the highest, is it getting oxidized or reduced? So what are we going to start with? Cu2 plus. And the ion is always going to be aqueous. And then we're going to add in aluminum solid. What's that going to go to?
Copper solid.
Copper solid,
Aluminum 2+.
aluminum 3 plus, aqueous. Now is that balanced?
No.
What do we have to do?
3's the copper, 2's the aluminum.
Okay, so we got to make sure we balance the charge. All right. Now calculate the standard cell potential. That's just going to be E. This is A. Okay, because and again we know that this was the largest and this was the smallest in terms of reduction potentials. We just looked that up on the table. So now V, E red, E cell is equal to E red, the copper, which is the 0.763. 0.3 what?
0.337.
Okay. I always get the copper and the zinc backwards. Minus the aluminum.
It's negative 1.66.
Which means we're going to add those, so we're going to get 2 basically. And then C, a cell is constructed. And we know all of that now. A cell is constructed based on the reaction in part A above. Label the metal used for the anode. So which one's going to be the anode?
Aluminum.
Aluminum. All you got to do is put AL right there. No explanation needed. Any questions at all about any of that? We feel good about those? Feel good about this? We're going to do good? We're going to do good. We're going to do well tomorrow? Last major test, last real test. All right. Prince to review. Let me see somebody's. The electrochemistry is part of another unit, so we're only going to do Okay, so you're going to do multiple choice numbers 12 through 20 on page 307 to 309. Okay, and then FRQs. Five and 6. Okay, so you should have plenty of time to get those things done today.